Hello. This is going to be the first lesson or topic in algebra, and you'll be looking at a skill that you've already practiced in surds. So that's awesome. The activity will be this worksheet for you. I just want to talk through three ideas, which are this one, connecting your prior learning to the topic, and a little bit about the language of algebra, and then a little bit about the history of algebra. So I might actually start with this here. And none of this would make any sense to you right now because it's just my notes. But let me tell you a little bit about how and why algebra was developed. So in ancient civilizations, Mesopotamia and Egypt, the civilizations there developed structured societies. We had agriculture. There was the concept of tax as well. And so those things needed explanations, general explanations. And so algebra was developed out of necessity, really. And the example that I go back to is agriculture and how area, the concept of area, was developed in theory due to algebra, due to agriculture. So people were describing the size of their paddocks, the space that those paddocks would take up, or the space of the land that they owned, that it was, used for agriculture. Then they could use a formula like that as a standard way that people can communicate the size of their paddocks. So instead of having a generalized verbal description of like it starts at the foot of this mountain and it extends for 40 horse lengths or until the end of the valley or something like that. The ancient Egyptians developed the formula, the area of this rectangle, the space that it takes up, well, it's the distance along this edge, the length, multiplied by the width. So for everyone who had a rectangular paddock, roughly, they could go and estimate the amount of space that they had. And that would be useful for buying and selling property. It would be useful to figure out how much grain or maize to buy to then sow and all of that sort of thing. It was also used in taxes, but I don't have like a good example of that. Yeah, okay, so that's enough on that. Now, a little bit about the language of algebra. We'll go to that second. I should have put them in order, but anyway, I didn't. Let's go to adding and subtracting surds. So you have done this work. And if you remember, a like surd, we're using the same idea. A like surd example is square root 3, square root 3 here. And remember how we just add or subtract. So 4 minus 6 square root 3 is negative 2 square root 3. And then we look for the other like surds. So that'll be the square root 2 and square root 2 here. So negative 2 plus 5 is 3. So it'd be 3 square root 2. We're doing exactly the same for adding and subtracting these algebraic expressions. So the word algebraic expression, this is a surd expression. Algebraic expressions are ones that have terms with the pronumeral or the letter in them. So in this very quick example, we have a 2x and we have a 5x. Notice how they only have x's in them. So they're like terms. So then we can collect them. 2 plus 5x is 7x. And there is no other like term or anything that can be done with that -3. Let's remove that marking in case that gets messy. So we just leave the -3 by itself. Okay. The last point I want to make is how we write x. Now, there's a reason why we use the letter x, and it's because the first written format was in a version of ancient Arabic, and the unknown term was a term that looked like x. In fact, you'd probably know, but I don't even think the Greek alphabet was developed by this point. So, but we still use it today. Now, x and times looks very similar. So when we have expressions like this one here, we don't write the times in. Let me show you how to simplify it. We have x times y. So that is just actually written as xy. And then we have 2 times -4, which is -8. And I don't even write the times in for that. Kind of like how we don't write the times in for the surds either, but we know there's a multiplication symbol in there. Now, we do it there because it's convention. It's become convention because we do it in algebra as well. So we join them all together. And we always put the numbers out the front. No actual reason, just convention. And then we have the letters. Doesn't matter what order the letters go in. I'll get you to have a crack. Have fun.